Okay, so it's May 11th. Oh, we're adding a bunch of Dropbox files. Go away. All right. Um, so it's finals week. So I expect everything's a little bit light this week. It was for me. I hope it was for you guys. You had plenty to do. Um, so let's just talk about what we did do. Um, so one of the things I've been interested in for a while is trying to replicate this map that's at the front of the home student center. So the other day I went into ARC and just sort of traced something that's pretty similar. I didn't try to do it exactly, but trimmed around all the features that you know, seemed about right. I included this little offshoot for Annie Glidden, um, which is kind of this little square area down at the bottom of that. Um, Not really necessary, but actually it's interesting cartographically because it's a good orientation piece. So I don't know that I want to keep that in there, but it doesn't really hurt anything because these portions extend about as far south as that, so we're not really losing anything. Um, and I thought, if we're making these things for the blind, it might make a good thing to kind of make a good landmark that people could easily sort of say, well, that's this or that. Maybe something worth talking about in the AutoCarto presentation, because I think the tiles themselves have my sense is that it's probably going to be difficult to stay oriented in just a flat tile, right? Especially, well, we can talk about those a little bit later on because they're almost done. But anyway, so we'll see if that works. I included the bounding box for this polygon as well. So if you are sectioning this thing out of a LiDAR data set, you should be able to use these. So these are in State Plane, Illinois East. They're in feet. So keep that in mind if you're trying to merge a couple of clouds together. Actually, I ran into this trouble, which I'll talk about here in a second, but State Plane East in feet. Not our usual. The advantage using State Plane Illinois East is that the roads are going to be more north, south, east, west instead of UTM where they'll be just a little bit crooked. So it's probably I think that's probably worth doing. This tile itself is in the O365 folder in Neal and a DeKalb LiDAR tile folder if you need it, as is the bounding, yeah, that's the bounding box. So I sectioned out the 2009 LiDAR dataset with that. I put a couple of the lines from LAS Tools in here. I was using Neal 1 to do it, and it's trying to access, there must be a liblas install somewhere that it's trying to access, and some of those have the same name. So last to last, for instance, has a liblas equivalent. So something in the path it's hitting that first. So I had to put a full path to the LAS Tools version of this. So that's why it's C:\last tools. The setup for this is pretty easy, just to kind of, I'm trying to get you guys a little bit more exposure to LAS Tools because it's really powerful. Input file was all of the LAS tiles. I actually downloaded from the Illinois Height Modernization Project because we just saw a couple of weeks ago that they had posted that. So I thought I'd give it a whirl and see. The whole file is zipped and it's only 25 megs. So they must have really, or not megs, gigs. They must have really compressed it, which is great because you can just pull out whatever little pieces you wanted. So I just pulled out all of the DeKalb Township. So it's sectioned off. I wish we had a good map of this. That's sectioned off by township. So I don't know how many townships we have in the county, 20-some, 26 or something like that. And each one has maybe 20 tiles. So it's like DK01, DK02 for DeKalb Township 1, 2, 3. Most of the campus is on DK22, but there are pieces of it that are around. So I just merged the whole thing into DK.las. So that's the whole DeKalb Township if you're looking for something. That'll be in that folder. Oh, actually, it won't. Sorry. No, it is. No, it won't. What can I do with that? Oh, that's right. So, okay. So I brought it in. I brought them in, but then I kept only these. So this keep XY argument will basically do a clip out of that by specific. So it's weird. It's the minimum X, minimum Y, maximum X, maximum Y. So that's why I included both bounding boxes here. This is like according to our tiling system, so top left, bottom right, and then this one is the min x, min y, max x, max y. So copy and paste job. So that's cool. That'll just pull out the square. I hadn't actually done this, I don't think, with a LiDAR data set, but you can clip out. So LAS clip is the tool within LAS tools to just clip out a polygon. So I took the polygon that I made and clipped it out. So that's this one. So using the boundary shapefile, pretty handy. I love how easy LAS tools make these jobs, right? It's a very intuitive kind of command line interface. And once you get used to sort of some of the syntax, like it's super easy. One of the catches, Earl, if you're working with stuff, is this dash merged. By default, when you do things like LAS to LAS, it will batch do everything that you put in. So every input file you scoop in, there's going to be one input file on the back end. Okay. So it's really useful if you wanted to do something like zip them. So LAS zip is a tool to compress them. And so it's really handy because you can say input all of my LAS files and then output all of my LAS files, and it'll do each one individually. So you don't have to write something that'll loop over them. It'll automatically do that. But this dash merge will say, put them all together as one and then do this thing. So it's a really nice, it's a little odd, but.
Would you be able to merge then zip the same command line, or does that be the second?
Same command line.
So you have to have dash merged first, and then it'll process the merge, then you dash zip or
it'll actually read all of the commands. They don't need to be in sequence. So the main thing is that you'd have a dash I, what are you reading in? You've got a dash O, what are you writing out? And then, excuse me, and then the dash merged is gonna, if you did just this one without the merged, this is really weird. It would do each one, but it would write each one as the same file name, so it would overwrite. I've run into that before. It's a strange. It makes sense once you get used to it, but it's a little bit weird. But yeah, you can do them all in a single step. LAS to LAS is really good. The LA, so as a bit of background, Matt, the LiDAR files come in LAS, right? So that's kind of the default spec. But that's kind of a big format. And so people, since that spec has been developed, have come up with better ways to sort of write that format. And so there are kind of a couple of competing versions. So the one alternative is to just take an LAS file and like use a regular zipper and just zip it. That's okay, but it has to be decompressed before it can be read. So like the LiDAR for DeKalb County was just an LAS file that's been zipped, right? Like any other file. But then there's this, so the guy that wrote LAS tools wrote a compression algorithm that does it. Those can be read directly. They don't need to be and so those will have a LAZ extension. So those are like an LAS zip format. It's a different format. Anyway, so like Cloud Compare can read those directly. Lots of programs can read them directly. But Arc is famously developing their own compression scheme. But this one's kind of caught on. So the LAZ files are like, I don't know, let's say a fifth or a tenth of the size of the original one. So it's a significant savings, especially since, so going from like the DeKalb set, your uncompressed stuff is like 100 gigs. And so if you can get that down to like 20 gigs that's like directly usable, then that's better than a sort of zip file. Anyway, little bit of background, but now you've been into that a little bit. I colorized them. This time I got a full extract. This took me more time than I want to admit because I forgot that these were in different coordinate systems. So the orthophoto was in UTM, and the other one was in state plane. And so when it tried to attach the points, it would just come out as not colored, and I couldn't figure it out for the longest time. And then I figured it out. So I'm dumb. So watch your coordinate systems. So I've got two different versions of this. One is going to be DK colorized.last, and that's going to be the square, just the bounding box, which might be more useful for some of the tiling and processing that we're doing. And then this is the DK.shp or underscore shp. So that's the one that's got the nice. So I think it might be pretty cool to just print one of these out. You know, we can make a model of it, and we can do that today using kind of the techniques that Earl pioneered. We can do that stuff and just print one of these neat looking shape. So that would be cool. It would be cool. So that'll be fun. And I think at that scale, it won't matter that there are things like trees in it. It'll look a little bit, well, we can talk about that later. But anyway, so here's the file if you're looking for it, dk shape colorize.las. I put the full path in there, but basically it's just on O365. I've been screwing around with the reach a lot. That reach is kind of fundamental for getting us a really, really highly accurate position. So whether we're going to pair it with a LiDAR, whether we're going to use it with a drone, like if we can get this really down to like centimeter precision, then it's going to improve our fixed 4D models. It's going to cut down on processing time. It's going to there's just a ton of good reasons why this might pan out. But I've really had a hard time getting the accuracy to the point where it really has advertised. So last week I presented on using the paired unit. So I had one unit in my garage ceiling, pulling in a position and broadcasting its position to a Ntrip server caster. This week I used the CORS data, the correction data from Aurora to do it. It was easier than I thought. So there's a nice little web interface that I guess I didn't put the URL to, but if you just Google CORS correction, you'll get the page that you need. Just put in the date, download the whole thing, and pull it in. The stuff that I pulled in, I had to convert. So these tools, this RTK-Lab tool set, to do the post-processing, there's RTK post. To do the conversion, there's RTK convert. And so it'll take the Aurora correction data and translate it into, no, that already comes in that right format. Scratch that. Anyway, RTK post is what you need. So I did a comparison of how good is the RTK correction with the CORS station versus the static one. So I don't know if you guys can see that where you are. The green is what I presented last week. So that's the base station from the garage. The orange is the position from the established based on the Aurora corrections. And then this is the nominal true correction, and you can see in the orthophoto that the orthophoto has it right there. So the orthophoto is off by, so this whole thing is like 2 meters, which means the orthophoto is off by 1 meter, assuming that this is the absolute correct position, which Corey insists is true. So what do we need to do with that? I don't know. Do I have another slide? Yes. So I want to try to get this station on the roof. I bought a little, I don't know if I had this last week, a little USB power thing. Maybe I did have that last week. That's been handy because it's pocket sized and it's easy to transport. We tried the solar power thing. It's hard to tell how long that lasted, but a while. It extended the range a little bit, and if we want to try to keep it there a little longer, we can do that. But I hear that there's power up there. Anyway, I talked to, so the catch was, how do we get it transmitting? So it just needs internet access to transmit its correction. We can use like a hotspot, but then somebody has to leave their phone on the roof or something. My laptop can be a hotspot broadcaster, so we can potentially leave that up there for an hour or whatever while we go do our thing. I had that email into DoIT to see if we could get it online. They came back and said that they can't do any MAC address filtering, which is not what the CIO told me. He did suggest that we could use NIE guest, which is actually a pretty good idea because basically anywhere is going to be transmitting the NIE guest thing. And as long as we're just transmitting signal out, it shouldn't matter. So I think that's probably a good option. However, when I was fiddling around with it, I noticed that it had a WPA-EAP option, which includes an identity and password. So I thought I might just be able to put in my AID. Unfortunately, that causes some serious problems. So what it's doing over there, so I did it. So essentially I did that. I brought it in here. And then ever since then, I've been unable to connect to it. Well, so I was like, well, and I tried a bunch of stuff, like it wouldn't make its own hotspot, like it wouldn't connect to my wireless. So once I put this stuff in there, it's like incommunicado. So I had to flash the firmware last night, and I hadn't done that in a while. So that fixed it. The flashing was kind of annoying. All I can say is that if you ever have to flash one of these things, there's a nice little workaround, which basically entails throwing the USB drivers to talk to that thing into the installer file. It was kind of, I mean, it's not that bad once you follow the directions, but if you don't follow the directions, it looks like it's just never going to work. So anyway, it also couldn't connect on USB 3, but it did connect on USB 2. So there's little tiny things. I don't know, just bookmark that in your brain if you've ever got to do a firmware flashing on this thing. Follow the directions and use USB 2. Anyway, I was like, well, maybe that's a freak occurrence. So last night I added the NIU wireless in again with my credentials, and it's doing the exact same thing. So that's what it's doing. It's got a solid green and then this flashing blue that indicates it's searching. And then it just was never able to connect to anything again. So I haven't tried it. I wanted to throw it in the window and see what happened, but I'll have to, yeah, I don't know what, I don't know. I'll probably write them an email and ask them if they know why that's doing that. But I think this is the other big thing I got done over the week. So we've been making these 3D models for a while. I don't think I've shown this to you, Matt, maybe, but Touch Terrain is an Iowa State project that lets you take DEM tiles. So it's basically what we're using, the Touch Mapper for the blind stuff. It's basically a web equivalent for that for DEM stuff. It was done by some geologists, and it's pretty cool. The only problem is that it works better on smaller areas than bigger areas, and you can't cut polygons out from it. So it's just a tile, which is great for an automated tool, but I think that these kind of custom pieces have a lot of value. A lot of people like this, and this is way cooler than if it's just a square, right? So I wrote a Python script to do this processing back in the day, and I've basically been modifying that Python script every time I need something to run. But it's super fiddly. Every time I want to do it, it takes me an hour. Like, something always goes wrong. Ideally, I would fold that into like NeilPy, and like it would be an easy thing, and I hope to get to that point. But there's no reason why we shouldn't be able to do this in Arc. Shouldn't need Python to do this job. So the mechanism, basically what we're using is this sort of nice feature of Cura, which is that it can read a grayscale PNG and make a model out of that automatically. So all we have to do is produce a PNG that has the right values, and that'll do the rest. So it's this great loophole. When we discovered this, it was super exciting because that opened up a lot of doors, because it's a lot easier to produce a PNG than it is to produce another thing. So last week I had to make this. I told Courtney Gallagher that I would make this model of Africa for her when she goes on her field trip, and I thought this was a good chance to do it, and it was. So essentially, the gist is you need to take a DEM and you need to make a PNG out of it, right? And that's not that much different than every map that we've made in 459, right? Like, essentially, that's what you're doing. So the trick is basically, you read in the DEM, you clip it, but the magic happens. The first thing that you do is you rescale the whole thing from 0 to 1. The nice thing is that once you clip it, when you do the clipping thing, it sets all the values out, or there's that checkbox to set the values outside of your polygon to no data. So it is a square image, but it's got all these no data values. So you do that, and then you can run this like rescale from 0 to 1. So now your minimum height is 0, your maximum height is 1. And then you essentially are going to apply, you're going to rescale it one more time. So then you rescale. The idea here is you want the background to be 0, like a 0 height, right? So you set that to black. And then you're going to set the minimum value to a value of 8. So that's going to be 8 layers, if you think about it. So this is like number of layers. And the layers don't have to be 0.25 millimeters, although that's what you always use. So the upshot to setting your base to 8 is that your lowest elevation is going to be 2 meters off the ground. Not 2 millimeters off the ground, right? So that gives you a base thickness of 2 millimeters. And then you set your top to be whatever you want your thickness to be. So in this case, like I find with a lot of stuff, like 15 millimeters is a pretty good height, so centimeter and a half. You peg your highest value to those 8 layers plus 15 times 4, right? 4 layers per millimeter, 15 millimeters, so 60. So it goes from 8 to 68, and then you set your background of the map to 0. Are you guys following me? I don't think I'm explaining this super well.
I mean, yeah. I mean, it's a lot of, not a lot of stuff, but it's just. I mean, it makes sense. Yes.
So I think we can set a model builder tool to do some of this stuff, which is I think the right way to do it. But yeah, I mean, you can do the full thing in 15 minutes instead of once you kind of know what you're doing. But yeah, it would be nice to be able to set things like the vertical exaggeration, or I think things are going to get a little tricky kind of quickly. If not impossible, certainly, but like a lot of pesky details. This is why the script is so annoying. Like setting the vertical exaggeration versus setting the absolute height difference. So I've actually found that setting the absolute height difference is more important than setting the vertical exaggeration. So you just set it to 15 millimeters, and then it always scales it accordingly. I don't know. It seems to work better that way than the other way, but we can talk about that. Okay, and then you just export it as a PNG. So the background is 0. You bring it in. You set a base of 0, and what you'll get is a square, but the square where there's no data values is going to be a height of 0, and so you'll have this model. It's pretty neat. The only thing you can't do is you can't. I don't think you can rotate it, so it has to be printed orthogonally, like square, right? You can't. So, like for instance, if I wanted to make this map of Africa, I would have had to like rotate it on the print to be able to get it to print off that way. Because I could make that 20% bigger if I could twist it a little bit. But
it's actually counting the bounding box.
Yeah.
It's okay.
Exactly. So yeah, I don't know. But anyway, anybody can do this, right? We can make I wanted to get a YouTube video up to kind of explain how this is done so that you guys could kind of follow it along. And I want to do that. And how do you guys go through and make one? Because it's really great. I mean, now you can take, like again, you can do this in 15 minutes, 20 minutes, and make any polygon you want. So now, if we want to make our big map of the United States with all of the states, like super cool, like really excited to do that. The SRTM tiles, like instead of making them all, I can just sort of show people how to make them all. I still kind of want to make them all.
I was just thinking about that because that's where I was going. Because you were setting, what's important is setting that max height. If we do go ahead and make something like the whole United States model, we would have to actually scale up that max height, going from something between Florida for the absolute sea level.
Yeah, we have to do that calculation and like peg that top to 255,
right? And
then everything else is whatever it is. So the disadvantage to that is that your tiles could get really thick, right? If you're on the Tibetan Plateau, your tile's going to be like that thick. But you can always, in Cura, you can always cut off the bottom of the model. So even though you make it, you can then do a second step and say, cut off the bottom 20 millimeters, right? So if you're just printing Tibet, you can do that.
I'm just trying to think about how they're going to mesh because we get the whole nice gradient going up from like Florida up to the Colorado Plateau,
Yeah.
Really interesting because
I'd love to print something out using this.
Yeah. So let's make that a goal for this week. I'll try to record the YouTube video. I'll put the steps. I'll walk you guys through it once, and then let's see if we can make this kind of a good foolproof process. And you guys can make your own whatevers. But I mean, it opens up so many doors. The polygons are just so much cooler than the tiles. I could give her. You got to see it. I don't think you got to see the Africa one.
I don't think so.
I made an Antarctica one, but I was telling Earl that the polygon for Antarctica does a weird thing around the date line, around -180. It kind of folds in this strange way. It's not GISs surprisingly don't handle the dateline all that well, and Arc does it better. QGIS handles it really badly, which is fascinating. But it just doesn't come up that often. So people, it's like one of those bugs that I guess people just put off and put off. But yeah, it's not correct.
It's basically trying to wrap itself around
I think so.
the end of its grid matrix or
Yeah.
something like that.
Yeah, it's weird. It's weird.
Could just be trying to tell us the world is flat. Like,
Proof.
there's some proof. I mean, someone messed up. And they're kind of, you know, someone who wrote Arc or whatever is like this is the message. See it.
Well, we just missed another one of the International Flat Earth Conventions.
Mm.
Uh,
Yeah. They'd love us for making all these flat maps.
Can I just prove I don't see that curve?
there's no curvature on that.
There's no curvature on
Which would also be pretty cool. I think one of my ambitions is to make an actual 3D printed
that.
globe,
Right.
which would be really cool. I'm not even sure how to get started with that. I mean,
It shouldn't be much more difficult. We're just gonna have a lot of infilling because you'll have to actually print it with.
yeah, but how do you make the model? Like, I don't know how you even, because you'd have to introduce the curvature in there.
Yeah.
But I don't know how you do that. I have no idea. Like, it should.
Project.
Yeah, man. Like, so what it would look like is like Sammy's map, right? What you should see when you look at the DEM is like it coming up at the top. I don't have any idea how you make that, but it should. I guess you'd have to.
Can you like clip out of like our globe or something like that?
That'd be too easy.
Can you clip just a tile out of like our globe?
Maybe.
Because
Yeah.
it projects into the sphere.
Yeah. Yeah. Well, I think it's worth looking at. I think, I don't know. The trick would be load and elevation. I don't. Let's have a look and see. I was excited, and now I think it's not going to work. But we should look. Okay, so the other cool thing about this is that now we've got a mechanism to easily add things like a scale bar. Like all the extra crap that we haven't been able to figure out, we can now add that in there just graphically. Right? Super fun. So I noticed that in Arc, if you guys can dig this out, there must be like an anti-aliasing setting on the edges of the text, because when I made it, it worked, and you could see like Africa like popping up off the model, but it wouldn't. The edges of it were all weird. You know what anti-aliasing is when it
Tries to like
smooth the colors? Yeah, it didn't look right at all. So I thought maybe bringing it into like GIMP or something to add the text might work, or maybe there's a setting somewhere in Arc, or maybe Arc Pro. It's definitely a solvable problem if somebody is interested in sort of figuring that out. To test it, all you need to do is sort of try to print a gray tile with raised letter Tether off of Arc and see if you can make it happen. Get somebody started on that if they're interested. But anyway, pretty exciting. Other stuff that happened this week, I got contacted by a former student who's actually the one who helped me make still have our blue LiDAR tile back in the day. One of the first students, undergraduate students that I worked with here, Steve Bargaski, is now working in GIS in Arizona, and he had asked how we did what we did, and so I told him he uploaded the LiDAR files, and I told him that we could do it for him. So whether we want to use this Arc method or the old MATLAB code, which is what we did, or the Python code. For the town, the LiDAR maps that I made, the vegetation was removed with Smurf. So now that we've got Smurf ported into Python, we should be able to do that. But I still have not ported the tools that I used in Python to actually construct the models. So we'll see. I also got contacted by Annabelle Ford. They're doing an article in American Archaeologist about LiDAR use in Central America. So they're going to talk to the Chases. They talked to Annabelle. So my name is going to show up in the article, which is exciting. They had a couple questions about bone mapping. It was an incredibly frustrating experience because he was like, so you're telling me bone mapping is better than other things, but why? And then when I would say why, he's like, well, that's really technical. Can you,
That's all
how do you,
is technical.
I don't know how to explain that other than, I don't know. I don't do a lot of public interfacing. This is actually something that Walker has his students think about a lot, and I think it's a good idea because it's crazy frustrating trying to explain and not be wrong. You know, like for me, there's so many things that are like this like mushy understanding. It's like not quite right, and you don't really. And Alex has had to deal with this. Like he's trying to make these claims about how cities can initiate thunderstorms, but like having to explain that in a way that's like correct and not hyperbole is really hard. Anyway, it was a weird experience. I'm excited to see my name in print in American Archaeologist, but I'm less excited to see all of the errors that are going to be in there in the end. I also got, I don't even know who this person is, Jan Meerman wants to prepare some bone mapping thing for some project he's working on. So I was like, at this point, I'm like, sure, I'll make it. The more it gets out there, the better, and it doesn't take me that long to do. So, have you run into that name?
For some reason, that name seems like I read it in something that when I was digging through stuff for visualizations.
Okay.
I'm trying to dig back because this is a weird name.
Yeah, yeah. Seems like a.
Jan Oceanman.
What's that?
Oceanman. Meer is ocean
Oh.
in Dutch.
Oh.
Or sea over there.
Yeah. It was. I think he had mentioned that the LiDAR data was coastal. So.
Of course.
The RU purchase is due Monday. That's been hard. I've got about $700 worth of stuff picked out. I talked to the people at SpectraWorks that have the carrier board, the nice big fat one that would simplify all the wiring. I guess it's out of stock and it's due to come in June. So I got to figure out how to spend $2,000 worth of stuff. One of the things I want to get is a tiny drone with first-person video that's going to interface with the new Tyrannus controller, which is sort of like a cross between what we're using for my drone and what we're using for the other one. It's kind of a big BP. It's kind of a standard. It's the one that Sammy used for his project. Anyway, so we can use that and then fly the smaller drones. People can get used to sort of a bigger controller in a safer space, and then they can. I'm thinking about putting the first-person goggles on the list because what the hell? So that'd be pretty fun. We can get that going. But yeah, all of it's oriented towards this drone project, and I got to email the guy in Mexico about that. I didn't do anything on DeKalb-Tree's project. I'm kind of dragging my feet because the whole thing needs to be rewritten in Leaflet, and I just haven't had the time. And then I did a flight test, excuse me, extending the drone arms out. It didn't really seem to make any difference. Rob thought that maybe there was still too much stuff around the arms that was disrupting the airflow and making it too inefficient. So I'm trying to kind of I've got the arms pushed out as far as they can go. It's 17.5 inches. And I just need to rewire the connection. So maybe we can get to that today. If that doesn't work, I don't really know what else. Balance, maybe. If it's unbalanced, then it wouldn't fly as well. I don't have any other good guesses as to why it wouldn't fly a lot longer than the Iris.
Maybe we do need to put a shell for it. I'd get a lot of drag on it.
It's just hovering though. Like it shouldn't be. We do need to build a shell for it, but I don't feel like
airflow over it though. You know,
that I would believe if it were flying, but if it's just hovering, like you can't
it's
really be.
still trying to drag the air around it. So you're still getting a lot of turbulence on it.
Maybe.
So you're creating that downdraft.
Yeah, that's possible.
So
Okay. Yeah. So we'll work on that. If you guys have any ideas, I'm all ears. It's I haven't done the flight test with 2 batteries yet, so I don't really know what our operational range is. I also noticed that it must be set for a much bigger battery than we've got because when it got down to 10.4, it told me there was 80% of the battery left. And so the capacity for the battery that's in the system must be set to like 10,000 milliamp hours or something. Like it's crazy high. So I did notice that the because it tracks the amperage that it's used. I did notice. What are you gonna say there? Oh, I looked up what the minimum voltage is that you can fly safely on. I guess the 3DR Iris, if it bumps down into 10.4 for more than 10 seconds continuously, that's the low battery alarm. But they'll fly all the way down to 9.8 or 9.9. So it's got a bigger window before crashing. The main thing is that when the ESCs hit a low voltage, they will stop to protect the battery. So that's when it will fall out of the sky. I don't know what that limit is, but it's good to know that it's more around 9.9 than it is, 10. Because I've definitely flown to like 10.1 and wondered if the world was going to end. And the difference between 10.1 and 9.9 is probably like a minute and a half. So that's a pretty good window. That's 10% of the flight timer or so. Oh, this is the wrong slide. That's an extra slide. Okay, so basically same goals as last week. I got a lot done, or I got some stuff done, but nothing really crossed off the list. So we'll just have to keep after it. All right. 36 minutes. Okay, our Reach RS unit is, or actually it's not an RS, our regular Reach unit is not working. We set it to go to an enterprise Wi-Fi login, and now it won't stop searching. So we are going to follow the steps from the firmware reflashing at Reach RTK. So it looks something like this. These are great instructions. So you're going to need to download the firmware itself, and you're going to need to download this tool. You're also going to want to follow this simple workaround, which basically involves downloading a separate driver and folding that into your install. So I've already downloaded all of those things, so here they are. So we're going to start with, so this is the Intel Edison setup. So that's unzipped here. So we're going to run that. So the whole thing is going to install a little Edison flasher. So that just takes a second. Okay, that screen's finally up. You can just kind of click through most of these screens. You're accepting the license thing. The main thing is that you're going to drop your USB drivers into this directory. So if you click on this, you're going to get taken to the little temp directory that was just created by the installer. And if you go back to here, you're essentially going to drop your driver installer in that directory. So our drivers are here. So the if you open up the Windows workaround, it's going to have a link to this file. Oops, somewhere there at the top. It's the standalone Windows driver, so there's the URL for that. So you would have downloaded that. Here it is right here. So we're just going to copy that into the installs directory. All right, so now we can continue with the install. What it would do is ordinarily when you hit the install drivers, it would have contacted the Intel server and downloaded those. But now it's not going to have to do that contacting. So it's going to unzip that directory and go through. So here it is installing the USB drivers. So you only have to do this once. The next time you run this, the USB drivers would have been installed on the... Okay, so once that's done, you're going to get to this piece here where it says USB drivers are installed. Again, you're only going to have to do that once. And from then on out, you can just run the tool and you can just flash the firmware. So I've downloaded the firmware that's listed there. Basically, you're just going to browse for the reach file. All right, so this is the reach image that I just downloaded. You're going to grab the JSON file. It's a pretty big file, so you're going to hit next. Hit next. It's going to load it up, and here it's going to prompt you to connect the unit. So I had trouble connecting to a USB 3 port the last time I did this. I don't know whether that was just bad luck or what. I'm going to plug this into a non-USB 3 port. So it's going to start detecting it. And with a little bit of luck here, it's going to start flashing the BIOS. Great. So we'll pause the video while that runs. This takes just a couple minutes to complete. Okay, so it just went through the firmware. There was no additional dialog boxes. It's all done. So that is now done, and that's how you flash an MLID reach.
All right, May 11th, finals are finally over with today, and all project as well, so that's kind of a big relief. Great movie, by the way.
You've seen it?
Oh, like multiple times.
Great.
It's like one of my favorite Rocky films. I don't know why. It's just like such a, like, it just encapsulates everything that you think about what happened in the 80s in one movie. It
Yep.
just is like perfect.
Yeah. If I could show that during my World Regional Geography class, I would. Like, I feel like it explains a lot.
It really does. Like, it's so over the top. It's amazing. He is. I don't know what is it. He got like a degree in something like biochemistry or something like that. Crazy, but I didn't do too much this week. Obviously, on Wednesday or something, I set up trying to find the central location for these maps, which is at 1 to 1200 scale, so double the size of the other one, which is 1 to 2400. So I was just trying to find a nice central feature and kind of offset it so that you can get, didn't really cut off too many buildings on the outskirts. Obviously doesn't, cover most of the campus, but it gets the core of campus, which I think is where it's busiest anyways. And so that's the area that you would want to blow up as well. So I think that turned out really well. I wanted to make sure that the lagoon was featured in there because the water is such a unique feature once it prints on here. So I wanted to make sure that panel was on there.
You need to get another one of those boards going.
Yeah, I don't think
The bookstore still open?
I don't know. That's a good question. I'm sure it's crafts or something.
Yeah, I suppose.
I don't know what that's the other one. I don't think we can fit it on there.
I don't think so. Yeah. So what are your thoughts on this one? I don't want to steal your thunder here, but what are now that we've got a comparison of this?
Yeah. Well, I mean, I like how it explodes the view of what's going on. It's essentially east tiles pretty much. Plus the looks, right? So that's really the basics thing. Like blowing that up. It's not as easy. I feel like you're trying to fumble around building that are so close and all the paths are
Yeah.
that's not easy. So I feel like this stuff is
I'm interested to find out if, like a lot of these buildings use all of their character. Like, I don't know, like Altgeld has this interesting shape, right? But, like the parking garage is, I don't know, like I almost feel like this is too simple for this scale, so I'm curious to find out if things stop being useful.
Yeah.
And this is where the LiDAR would really, my sense is that the LiDAR and photogrammetry at this scale has to be simplified a lot, right? Like this is the only way that this works. If you add the trees in here, it doesn't work. But I think that I'm interested to find out if at this scale you can include the trees. And would you?
I would think so. Yeah. Like it does make sense. Like for something that's this scale, I feel like something that's as simple as this is probably the best group. For once you can blow it up and all that noise is not noise, but all the clutter isn't as much of an issue.
shapes are almost too generalized, and there's considerably more open space going on.
The thing I do like about this is that the paths are all linear. Although I don't like, the path network is overly complex. So like the roads, like there's 3, which I assume is sidewalks and the main road.
Which I wish that could. I mean, you can probably go into the the code and switch. I wish that the road was a different texture, or dotted or something even.
So this is interesting. So this is Lincoln Highway, and that's got a different texture, right? Right. This comes out, but I think contributing something like we were gonna. So the touch mapper is on GitHub, right? It is. So I think that the magic would be if at different scales, different things got included.
I think that the regular roads have the same textures in, but they're thinner, so you don't kind of think like it's just like
I think it would have to be.
Yeah, it's kind of like a double. It's got like a little groove in the center. It's you're feeling that you kind of just think it's like something that happened over.
You notice a lot of the things that don't make it into OSM, like this shape, and grade, and then that's the bridge, right?
That's the little
But there's a bridge that goes across.
no, bridges
The
on
bridges go around.
Yeah.
So that's
So what are these then?
that's
the street. They actually not feed into the pond. They don't have pond. You got that pond sometimes it's not added.
Right. Yeah, we used to have pond.
And then you get a little bit of
It'd be a water feature.
We got our little Hershey kiss here again.
or you can have these porch marks.
Yeah. I was gonna. Yeah, I mean, not too much, but it is like considerably more than any of them here. But it seems like almost one at a time with this.
Well, we were prepping for AutoCarto. We really want to think pretty. I mean, we can do this and basically sit down and talk about what the strengths and weaknesses are of these different approaches and how this works, what scale, and the generalization. Like this is all good stuff. So we'll maybe that's something I can work on today. Get some stuff on paper. Presentations in a week and a half. So we need to start aggregating, all of our lessons of building all of these maps for the last 2 years. Need to kind of find their way into a presentation. But this is exactly the kind of stuff that they'll have no idea about, right? Like, the way that things are tagged and the way that they're auto-generated, these are the problems with it. It'll be good. But we wouldn't know this until we tried this out. So you weren't going to, were you?
No.
You guys good? Midwest?
Yeah.
And then the other, I guess, major thing I did this week was Dr. Fingal talked about creating an organized record system for keeping track of all these files and the source and any other information that we want to associate with it. So in Neil O365 website, under Touch Mapper, just to differentiate it from all the other stuff that's being printed, there's currently a folder for this 1 to 1200 scale one. I'm still working on the 2400 one to get all of that stuff in there. But it pretty much at the beginning it has like the basic parameters because with these, I'm not just centering on a building since there's spaces in between. I'm actually using offset too, and so that's kind of an easy thing to glare over. Also, like in the past when we have opened links. We found that it can sometimes reset it to like default stuff, and so it's important to I just think to have this in there that the link isn't always going to be 100% true.
Okay.
And just to double check.
But we'll have the STL files in that same folder too, right?
Yeah. I mean those will be in there too, but just depending on how you want to do it. Like you open a link and you're like, why isn't this not the same as this?
Right.
This is why.
What this thing is.
We need to look at the feeling.
More or less.
So these ones have been centered on La Tourette Hall, yep. And then offset to the left and down a little bit, just to make sure that Lincoln Highway was in there, and then not clip off any buildings on the left. And so then in the actual PowerPoint is what it's in, and this is just kind of like the basic thing. It's just, a little diagram that I made just for simple visualization of what's going on. The OSM extent, what the tile's going to look like, so when you print, you compare to make sure it's the right thing, and then the link. So
You want to build the file location in there too?
yeah, the file's going to be in the folder.
I mean, but in your PowerPoint, give the location of the actual downloaded tile.
Good
If
idea.
you're saving them in the OS 360, 365.
Yeah.
you know,
Even
just
if they
put the file
move,
in
it's
there.
often I've moved folders before, but like it gives you a clue of like things you can find. So it's a good idea. Throw in a local file.
Okay, yeah, that makes sense. I guess I could talk about like why is it beneficial to put it in there just so in the future we're not trying to. A couple weeks ago something got messed up, and so we were trying to re-guess what feature was centralized on. It's just easy. I can forget in about a week. So if you 10 years you want to try to remember how that happened, good luck. And then also if like there's any issues that we run into printing and stuff, it's just a good way to kind of aggregate like with this one. Like we could write that home student center is having that little dot form on it. Could look at that in the future. Just take other information with it.
Before we move on, can I ask you to send me one slide, and I'll probably have to pare it down a little bit. But you had done some research into the guy that made TouchMapper and his story.
Yeah.
I think that'd be a good story to tell at AutoCarto.
Sure.
Since he's not an academic, it'd be good to kind of
Yeah.
whatever you can dig up and
Yeah, I mean it's not too lengthy. It's pretty much me from stalking him. So
great. That'll work.
and then a couple days ago you talked about kind of starting to play around with Cloud Compare. I got it on my laptop and was messing around kind of I guess with the Cal LAS file that you had put into whatever folder. So and then also started on like basic tutorials, but I honestly haven't spent a ton of time on it. Just most of the ones that I was looking at, kind of talking about, I guess bringing it in and like some of the basic stuff that you can do like color and stuff like that. So nothing I guess too advanced. I don't really know. I guess how much you can really do with this, how we use it, but I'm sure that's what you're going to teach me to do. So
Yeah, we can that's definitely the workhorse of the lab.
right.
Yeah, it's pretty awesome. We do everything.
Because there's quite a few tutorials as well that it was talking about stuff that I didn't really know if that's how we use it for output. I'm sure it's beneficial regardless. But,
Yeah, and I think I probably only know 20% of what that software can do. So we kind of use it to solve our immediate problem. But the more you can kind of explore and come back and say, look, it can do. Here's another thing it can do that we didn't know about. Like Earl taught me stuff how to use this. And
I still can't get the animator to work on my laptop.
oh, really?
I don't know. There's something about the codecs in there. But that's
Yeah. I had Alex work on a project with this stuff on visualizing radar data over time as a point cloud. And he was the one that was super cool. And he's the one that taught me how to do the animation. So you can use this and create these viewpoints and then animate a movie kind of like looking at the different, so stuff like, and yeah, so that's super handy. People love that stuff. Because it's hard to get a sense sometimes of the 3D structure of it when it's static.
Yeah.
The animation really helps a lot.
Okay.
Yeah.
So
I love that shape. I really add a lot of.
I'm really
Yes.
excited to see that like print out as a whole kind of thing.
Yeah.
That'll be super cool to see.
It's really good. There's another feature of this that I like, which is when I was paying attention to that polygon, they go to the edge of the roads, so the road will be on there.
Yeah.
I'm excited to see that. Sorry, go ahead.
So like what's kind of I guess like between you two like a very very generalized process of starting with the input file and then end result like a 1 minute kind of spiel.
Like right now?
Yeah, I mean
Okay.
because then it's kind of documented too.
Sure. Yeah. So the way that I do it, I've got a README file, and I'll send you that. So in the campus composite that I made to print one of those LiDAR tiles, I've got like a step-by-step of how we did it. So I'll share that with you.
Okay.
But as a brief explanation, let's see, how do we start? So first thing you've got to do, let me see if I can get the first thing. One of the first things you have to do is calculate the octree. So the octree is going to be sort of like a level of detail. What it does is it kind of divides it into boxes.
Yeah.
So you've maybe seen this before.
Yeah, in one of the tutorials, that was like the first thing he did.
So that one is pretty much automatic. You just calculate the octree and
Right.
it do it for you. It's really useful because it speeds up the time it takes to
Right.
move it around.
Yeah.
And it's also helpful for calculations down the road. So that's like step one.
Okay.
The next thing that you do is you calculate the normals. So the normal is the direction that's like perpendicular to the face. That's a tricky calculation because you're calculating it on points. So there's no face to the model yet. It's all points, and they're all. So what seems like it should work fine is actually really, really error prone. So figuring out how to do that. Typically, what happens. So that's also dependent on how much noise is in the scene. So the noisier it is, the harder it is. But so that's the next step. You'll typically have to go in and repair some of those. So there's lots of different ways you can create the normals. So it's just a tool in there. It's like edit, calculate normals, or something like that. But within that, there's a bunch of settings. Getting those settings right is kind of key. And then what I'll often do is I'll often repair it. So for instance, for the part that I worked on, the tall buildings didn't calculate right. So Zulauf and the Holmes Student Center in particular were bad. When you do that, what you'll see is that they're like different colors. So like on an RGB point cloud like this, if the normals are calculated correctly, essentially it'll look like an RGB point cloud. But wherever they're calculated incorrectly, it'll look black. And the reason for that is that the normal is facing kind of the opposite way that it should.
Is that what came up with when the Sammy Smith was doing it?
Yeah.
Yeah. Okay.
So it's an easy fix. You can actually just invert them.
Okay.
You can recalculate them. So what I'll typically do is I'll chop the building off, and then I'll recalculate it with the very center as the point you're orienting. So essentially to calculate the center of whatever that shape is, and try to point everything out from that.
Okay.
But that only works if you've got a thing, right? Like a building, right? Otherwise, if it's this, then the center of it is the center of campus, and all of the stuff would be the wrong way, right? So
Yeah, definitely want to do that in sections. You want to isolate the thing you're trying to find the exterior normals for.
Right.
Yeah, if not, I made one of the first mistakes I made doing like being one, and that just was a disaster.
So the normals calculation takes a long time.
Okay.
So on my computer at home, it can spend 2 hours
Really?
doing that. It depends on the level. It depends on the octree which you calculate it at, and it might be interesting to experiment whether you can get away with doing it at a much lower setting. So the higher the octree number, the more detail it is, right? But the octree is also it's only oriented towards the size of your feature. So like an octree 10 on this, if you cut that map in half, that's going to be equivalent to octree 9 on the other one, right? So the bigger the model, if I divide that into, this isn't how it works, but if octree is 10 is like tenths, then if I cut it in half, then now that's a different, now it's fifths, right, or whatever. So you've got it's not a static measure of scale. Anyway, octree calculates quickly, normals take a long time. Then the last step is the surface reconstruction. So that's where you turn it from a point cloud into a mesh. So it's kind of like a solid object. So that is the Poisson surface reconstruction. There are a couple of ways to do that.
And it depends on the type of structure you paint. So the Poisson, there's the Delaney, and there's 3 different types of reconstructions you can do for that.
Okay.
So
Yeah, I guess I always use the Poisson one. But
it depends on the shape.
Okay.
On the shape of the feature and more of the extents of it are.
Earl spent a long time on that stuff, so he'll be, especially so like making these building models. I've made one building model, and he's made like a lot. So he's the guy that knows how to do that stuff. I've done a lot of work with like the big point clouds at this point, so I feel like I can help you out there.
Okay.
But anyway, so that makes a mesh. I started, so then you need to have a thickness of it, right? Because if you think about it, you don't want your model shape, like if you're mapping a hill, right? If you've got this terrain feature and you make a mesh out of it, then that mesh, it doesn't have a bottom. So to make it a 3D structure, you've got to add a bottom. So what I was doing with this was taking all of the points and then dropping them directly underneath at 10 meters lower than the lowest point to form like a floor. It's not usually, I don't think I did 10 meters, but making like a floor, and then doing the surface reconstruction off of the floor and then the top. Okay. That's worked out okay. I'm not really satisfied with that. I think that there's still some work to be done to figure out. So the work that I did, the first LiDAR stuff that I did was I would turn it into a DEM, and then I would render it the same way that like ARC would make a tin. But then you can't get like a tree that comes out, which this can do. It can make something that bows inward, sort of like alpha shapes that we did. It'll follow the object terrain, right? Because a real object, like a 3D object, is going to go in and out, in and out. So that's what the Poisson or other types of surface generation will do. Is they'll make it, and that happens a lot. So like, around the buildings, like any overhang in a building, which is pretty common, right? Like whatever building that is, like this overhang right here. You don't want it to go straight down. You want that to come in. Right. Or like the bridge by the library, the one that connects those two. Like you want that bridge in there, and to wrap it around. So that's why the DEM method I think works at some scales. Like if it's really big, then I think it works. But for the fine detail, you have to do this later. So that's the basic step by step.
So then once you get that, like, how does that turn, like, how do you get that to, like, the printer?
So that'll output a PLY file, and then that'll just drag and drop directly in. Perfect. Yeah. Okay.
The one thing with that is, depending on the size of it, I tend to, it'll put out a very large PLY, which that will never load.
Yeah, you want to cap it at 50 is a good 50 megs is a good number. 80 is probably pushing it. If it's over that, I think that's going to die, and it won't do it.
Because I'll get something out of there, and I'll drop it into MeshLab, and I will compress it in MeshLab.
Yeah, so you can do in MeshLab, you can do like Simplify, which does a better job. Cloud Compare doesn't really do that well, so MeshLab is a good toolkit to process out those extra little bits that don't really add a lot of value. But this is a really coarse way because you can only do it with the octree number, right? As far as I know. So the jump between 9 and 10 or 10 and 11 is a big jump. And so you might find that 10 is too detailed and produces a file too big for that, but 9 is too coarse and produces a file that doesn't look good. Right. So that's where MeshLab can kind of bridge the gap.
Okay. Yeah, I try to work at as high of a level I can get on that and do this the best detail I can get, then I bring it into the MeshLab and I just use the Simplify. It will do some smoothing out, like if you like between the different, like these models. These guys I did them all in this method, and so you sort of see how some of them, these were like some of the smoothing will happen. Right. So yeah, it looks really
good. The stairs are great.
Yeah, I can check those stairs, man.
So this is the staircase that goes along the side. And I mean, like, this is amazing for how, I mean, there probably isn't even how you point density right there. So, like, this is really good. All of these surface details, right? Like, yeah. It's awesome.
Yeah, I tried reconstructing those manually.
By the way, I need to get out to the roof. So, let's see. This is the 6th floor. That's the 5th floor. Yeah, after the lab meeting, we'll
that whole thing about not being able to be on the roof, apparently they took that on out the other day to watch the storms and everything. I'm like,
yeah, but they talked about that at the faculty meeting. They said, like, better to ask forgiveness than better to beg forgiveness than ask permission. That's funny. Yeah. Okay.
So you'll have a lot of fun talking there.
Okay. We should see if the new version of Kira can handle those That'd be a nice step if we could.
What was the reason that we had used the
Old Cura?
yes?
The new one can't do DAEs, which is how a lot of our SketchUp models were stored. And we can convert them, so it's not a big deal.
Right.
But it also couldn't. The interface was really weird. And I was like,
I know it's a lot different.
I don't
now.
have time to learn a new interface. And then I feel like it may not be able to do PNGs, but I don't know that
I'll
for
look into
sure.
that.
But that one we really like, so
Yeah, I mean,
That's
I guess like
I always use both. But
yeah, that's true. They're all archived. I thought like with maybe you can do it with this one too. I just haven't, but like you can actually go into each layer and kind of mess with the settings.
oh, really?
I thought so, like slicing them and stuff.
Okay.
Not this. I know the original Cura was specifically designed for the TAS,
Okay.
and the other main one, it would not interface properly. So I have tried to upgrade
Oh,
to the
really?
original, and it just would not interface with the machine right. It was just, yeah, it did not work very well. So thankfully, it looks like they made it more.
Right, and I mean, I'm kind of basing this off of like obviously people who like do 3D printing outside of this, like they really get into like the nitty gritty kind of stuff to like do crazy things.
Yeah.
And so a lot of them were talking about how, like at least in a new one, you can like I said, dissect each layer and kind of tweak things or whatever. So I'm not sure what there could be potential benefit to what we're trying to do.
We should look into it for
Okay.
sure. So if you want to do that,
Yeah, definitely. I could do it on my laptop, so this could stay on there. But I think this about really wraps it up. Goals for this coming week to create the same record that I did for the 1200 scale one, tile maps for the 2400. Get that all finished up. Continue learning and playing around with Cloud Compare. Look at the step by step that you put out too.
Yeah.
See if I can work myself to get through that process 100% without fatal errors. And then get back to the laser detection thing and tweak those parameters.
Okay.
That's what I'm saying.
Yeah, I'd still like to get Stacy and Gail in here at some point. But if it's the end of the summer, that's fine too.
Right.
I'd rather have something good and done than half-assed.
Right. That makes sense.